Hello and welcome. Today we're going to be taking a look at the interior angles in relation to polygons. So by the end of this video, hopefully you will know the sum of the interior angles on different polygons. So that's what all of the angles add up to. And then we'll be able to work out the size of an interior angles inside those polygons. So just a little bit of a reminder of what a polygon is. A polygon is any 2D shape with straight edges. So you've got lots and lots of examples there. We've got triangles, we've got any type of quadrilateral, so any shape with four sides like a square or rectangle, trapezium, rhombus, etc. Pentagons, hexagons, all the way up to decagons there. So they're 10-sided shapes. Okay, so now the sum of the interior angles varies depending on how many sides that a shape has. So when you're dealing with exterior angles, that's a bit more straightforward because as you might have seen in the other video that I've done on this, exterior angles always add up to 360, but it's a little bit more complicated when you're dealing with interior angles. But there is a little bit of a formula that can help you with this. So this formula here, if you take the number of sides and subtract 2, then times it by 180, that will tell you what all of the angles inside the polygon will add up to. So if we look at some examples of this, so if we look at this one here now, an equilateral triangle, any triangle has three sides and three angles. So the angles will always add up to 180. So on this one, if you do 3 take 2, that will give you 1, and then you times it by 180. So it's going to be 180. With quadrilaterals, you're doing 4 take 2, which is 2, and then 2 times 180, which is 360. Pentagons, it's 5 take away 2, which is 3, and then you're doing 3 times 180 to get 540. And what you're actually doing when you're doing this is, I'll just show you on the diagram as best I can, you are splitting the shape into triangles. You're working out how many triangles fit inside that shape. So we can see on this pentagon that it splits into 3 triangles, which is why you're doing 3 times 180. Now, when you take this formula, if you are dealing with a regular polygon, so when a polygon is regular, as it tells you here, it means all of the angles are the same size. So once you know the sum of the angles, you can divide it by the number of sides. That will tell you the size of one angle. Okay, and we'll see that throughout some of our examples later on in the video. So now we're going to have a look at working out the size of these exterior angles then. So let's have a look at our first question. So this time we've got a regular hexagon. So what I would like to know is the size of one of the interior angles. So this one could be this one. They're all the same size inside this regular hexagon. So if you pause your video, then have a go. Okay, so first of all, we can see this has 6 sides. So if we do 6 take away 2, that gives us 4. Then 4 times 180 is 720. So all of the 6 angles will add up to 720 degrees. If we then divide that by 6, that will give us 120 degrees there. Okay, let's have a look at this octagon then. So again, pause your video and have a go. Okay, so here we've got 8 sides on an octagon. So if we take away 2 from that, that will give us 6. Then 6 times 180 will give us 1080. So all 8 of these angles here, all of them added together, will give us 1080. So if we divide that by 8, because there are 8 angles, that will give us 135 degrees. Okay, now we're dealing with a pentagon. So it's a little bit more complicated than this one because this is not a regular shape. Okay, what we've got here is what's known as an irregular shape. So that means all of the angles and all of the sides are different lengths. Okay, so what I'd like you to do is pause your video and see if you can have a go at this one. Okay, so we're dealing with a pentagon here. So remember our formula. 5 take away 2 is 3. 3 times 180 is 540. Okay, so that means that all of those angles add up to 540. So if we add up what we've already got, so we've got 95, add 123, add 86, add 117. That gives us 421 degrees. So the 4 angles we already know add up to 421 degrees. We've then got to take that away from 540, and that will give us 119 degrees for our angle X, just at the top of that shape there, that angle ABC. You'll notice the angle notation here. The middle letter is always the angle it's referring to. So it's A, B, C. If we were asked to do this one here, it would be B, C, D, and this one would be C, D, E, and so on. But our final answer for this one is 119 degrees. There you can see a fully worked solution to that one there. Okay, our next one then, we're dealing with a hexagon this time. So angle ABCDF, the shape ABCDEF is a hexagon. Now this one's slightly more complicated. So we've got a bit of a proportion problem going on here. So angle CDE, so that's this one, is 2 times BCD. Okay, so this one is 2 times BCD. So we want to work out the size of this one here. So it's referring to angle CDE. So you might need to think about this one a little bit more. So pause your video and have a go. Okay, then we've got a bit of a solution to this one then. So first of all, your first step is this one here. So the angles in a hexagon, if you do 6 take away 2, which is 4, times that by 180, we know they're going to add up to 720. Okay, now if we add up what we already know, for those 4 angles we already know, that's 519. Take that off your 720, that's your second step. Then your third step here, if we take that away from 720, there's 201 degrees left. And what we can see on this working out is we've used a bit of algebra to help us get to the answer. So we know that that is 2 lots of that. So if we label this angle as 2x and this angle as x, we've therefore got 3x in total. So we know that 3x has got to be 201. So if we do 201 divided by 3, that'll tell us x. So that'll tell us BCD, which is this one there. And if we double it, we'll get to 2x, which is the angle we are looking for, which is CDE, which is 134 degrees for that. You can do it as ratio. If you look at this as ratio as well, so if you've got, you can write it in a ratio of 1 to 2 if you want, so you can use your bar modeling. So that would be BCD, BCD for 1 bar, and then you've got CDE for your other bar there. So you'd still get 67 for each of your parts, and you'd be able to do 67 times 2 again to get your 134 there. So you can use bar modeling to help you on these as well. Okay, final question then. So we've got this diagram showing 3 regular pentagons. The fact that they're regular is important, and they're meeting at a point. So I want you to work out the size of the angle marked X. Okay, here is your solution to this one then. So now they've done this in quite a complicated way here. So we've got the exterior angle mark there. So if you do 360 divided by 5, that gives you 72. So they've done this in a slightly different way to the way we've done them. So that tells you what the exterior angle of the polygon is. And remember that the interior and the exterior as you can see on the diagram there, is always going to add up to 180. What that tells you is that each interior angle is going to be 108. So if we look around that point, we've got 3 lots of 108 there. So if you multiply 3 by 108, that'll tell you that that all adds up to 324. If you take that away from 360, you will get 36 degrees for that angle X that it's looking at on the diagram. Okay, bit of a long video today, but thank you very much for listening. It's quite a tough topic, this one, but hit subscribe and there'll be loads more videos coming your way, all relating to the GCSE Maths Foundation syllabus. Okay, thanks very much. Bye-bye.